I want to show you how easy it is to evaluate a definite integral using the TI-84 or TI-80 series graphing calculator. So I'm using the TI-84 plus CE emulator here. If we push from the home screen the math button and option number 9 for finding the definite function, the function integration functionality for a definite integral, you can just push number 9, or you can scroll down to number 9 and push enter. Either way, that'll paste the function to the home screen in math print mode. So you can see there's a place for lower and upper limits in the function in question and the variable that you're integrating over. So for section 3.4 with integration by substitution, exercise number 9, we were integrating 2x over 1 plus x squared with a lower limit of -2 and an upper limit of 2. So integrating from -2 to 2 is achieved by setting the lower and upper limits first. And again, the function is 2x over the quantity 1 plus x squared. I don't have the fraction functionality on this version of the emulator, but if I put 2x in parentheses and then followed by division and in parentheses 1 plus x squared, the calculator is going to read that as the function 2x over 1 plus x squared. So if we integrate that with our differential dx, where the variable in question that we're integrating over is x, those limits, the antiderivative is evaluated, and I think that we should have one more parenthesis in here just for good form. So integrating that function over the variable x from -2 to 2. If we push enter, you'll see it gives us 0. And that doesn't really help us to know why the value is 0. But if we were to go to our y editor and plug that function in, notice I've already plugged it into y sub 1. If we push zoom 6 to get a standard viewing window, this function acts asymptotically on the x-axis where it approaches the top of the x-axis as x goes to infinity, and below the x-axis x goes to negative infinity. We really don't need our y values to go much above -1, above 1 and below -1. So I'm going to change my window settings to -6 to 6 in jumps of 1 for the x values, and only -2 up to 2 in jumps of, let's say, 0.5 for the y values. Notice that when we graph this, there's a very nice symmetry about the origin for this function. And so when we integrate from -2 to 2, this region I'm kind of hovering over will be a negatively signed area, and the region from 0 to 2 will be positive, and the two regions are congruent, but one has a negative associated area, and this is the opposite of that area that's positive. So they cancel out, and that's why it's 0. But pushing second trace, option 7, and using a lower limit of -2 up to upper limit of +2, and when it shades the region, you'll see the blue region here as a negative area, and its opposite positive region is over here. And those two cancel essentially by adding up to 0. That's another good way to visualize why from the integral of -2 from -2 to 2 of 2x over 1 plus x squared dx is equivalent to 0.